Welcome to your lesson on complementary events and expected values. Notice here we have complement, spelled with an I, is an admiring remark, but complement, spelled with an E, means something that goes well together. For example, here the sauce complements with an E the steak, because the sauce goes well with the steak, whereas here the sauce complements with an I the steak and says, hey, you're very tender. All right, so make sure you know the difference there. Complement in mathematics is the important word in probability, so we're going to use that word today. So we're talking about probability. We're going to recap some basics, recap of basic probability. We've talked about probability being the study dealing with chance or likelihood of an event happening. All right, if an event has a 0% chance of happening, then the probability is 0. If an event has 100% chance of happening, then the probability is 1. And of course, probabilities can be any decimal value between 0 and 1, telling you the likelihood that that event will happen. We've marked generally probabilities in this way: impossible events, very unlikely; unlikely events under 0.5, equally likely. When you're right on that halfway mark, it's equally likely to happen or not happen. Then likely, very likely when it's close to 1, and then it's certainly going to happen, or it is certain when you have a probability of 1. Sample space is an important piece of vocabulary for this. It is a set of all possible outcomes of an experiment, or basically of all the possible outcomes in some kind of scenario. For example, when you toss a coin, the two outcomes are heads and tails. The sample space can be written in set notation, so I'm just highlighting all the important vocabulary. And the set notation means we use those curly brackets. There is a set of all the possible outcomes for tossing a coin, heads and tails. All right. An event is a subset, so like a small piece of the full set, all right? So a small subset of the possible outcomes listed in the sample space. So for example, if I define an event as event A and it is a head is rolled, then that event and the set for that event is this set right here. It is just a head, right? Rolling a head, rolling. Flipping and getting a head is the only possible occurrence in that event. Probability, basic formula of probability is you take the number of ways an event can occur, event A, for example, divided by the total number of possible outcomes, so basically all the outcomes in the sample space. So again, that n here always means the number of, so the number of occurrences or possibilities in event A divided by the number of possibilities in the entire sample space. Deck of cards, something that a lot of students were asking me about. Here's a deck of cards. We have 13 cards 4 times, 13 cards, each in these different suits. These are clubs, spades, hearts, and diamonds. We have ace, and then 2 through 10, then jack, queen, king. So if there's 13 times 4, that makes 52 in total. So if I said, what is the probability of getting a face card? Face cards are these ones, jack, queen, and king. So to use this formula here, we say how many things happen in this event. The event of getting a face card, well, how many face cards are there? There's these ones, and that's 12 face cards, so the number of face cards over the number in the entire sample space. So number of face cards is 12, the entire sample space is 52, so the probability of getting a face card is 12 out of 52. That reduces to 3 out of 13. That should make sense because it's saying you have 3 out of this 13, and each of these sets here, you have 3 out of those 13 that make a face card possible. Let's take some notes now. So let's use the packet you were given. And we're going to begin with vocabulary. Just recap what a complementary event is, again with the letter E, something that works well with something else. So the complement of an outcome is when the outcome does not occur. Well, the definition of the word complement was things that go well together. Why would something happening and that same thing not happening go well together? Well, the reason is when you put them together, they make up a probability of 1. So here's probability of an event occurring, probability of event E, and probability of an event not occurring, which is called the complement, is written like this, with the little apostrophe, meaning not E, or the complement of E. And when you add those up, they make 1. They always do, because either something will happen or it will not happen, and the chance of it happening or not happening together make 1. Therefore, if you rearrange this formula and you move this to that side, you end up with the probability of E naught, or the complement of E, being 1 minus probability of E. A simple example of this could be if the chance I'm going to eat pizza for dinner is 0.3 or 30%, then the chance I'm not going to eat pizza is 70%. And together, that 30% and the 70% make your 100%. So either it's going to happen or it's not, and you add them up. All right, here's an example right on your page. We have a bag that contains 4 blue stones, 3 green stones, and 5 red stones. 1 stone is randomly selected from the bag. So you reach in, pull one out randomly. Find the probability. Why is there 2 B's there? Cross one out. Find the probability that the stone will not be blue. There are 2 approaches you can take here. First, you can say probability it's not blue is equal to, well, let's see. Weird. Okay, so it probably is not blue is, well, if it's the other colors, which is it's green or it's red. So it will not be blue if there's a green or a red chosen. So probability not blue, written like this, complement of blue. Well, there's 3 green out of a possible 12 stones. So there's 3 chances for you to get a green out of 12. And then you add to that the probability of getting a red, which is there's 5 red stones out of this total 12. So chance of getting green is 3 out of 12, red is 5 out of 12. Together, that makes 8 out of 12, which is 0.67. And that is probably not getting a blue. It's basically saying, well, it's meaning not blue is meaning I'm going to get one of the other 2. So I'm just going to add up those probabilities. Now, there's another way to approach this. Probability of not getting a blue can also be written in that formula we just saw for the complement. So probability of not getting a blue is the same as saying 1 minus probability of getting a blue. All right, so we take 1 minus probability of blue. The probability of getting a blue one is 4. So 4 out of 12, that's your chance for getting blue. So that means probability of not getting blue is 1 minus that chance. And that means 8 out of 12. And 8 out of 12 matches our answer here. So that's the 2 ways to approach that problem. Some students prefer this way, some this way, but imagine you had many other options here. You wouldn't want to have to find probability of one and the other, and add all these different ones up. This calculation is much simpler because you just do 1 minus that one probability, and you always get the complement. So try the other example you see on your paper. Try using both approaches. Give it a try now, see what you get. All right. So it's about chicken, fish, and vegetarian options at a cafeteria. And you are a risk taker, so you ask your lunch lady, or in our case, a lunch gentleman, we have Sundays, to randomly select one item and give it to you. What's the probability you will not get fish? All right. So there's the first approach. To not get fish means you'll get the other 2 things, which is either chicken or veg. So you add the probability of those and you'll get the total. So probability of not fish is probability of, oh, why did I put that? Oh, veg plus chicken, sure, that works. I just put them backwards. All right, and then not fish is probably veg. Well, there's 4 veg options, and there's 2 chicken options. So the total is 6 out of 9. That's the probability of not getting a fish, because that's the probability of getting the other items. Now, the other approach is the one where you do 1 minus the complement. So probability of getting not fish is the probability equal to 1 minus probability of getting a fish. So 1 minus chance of getting a fish is 3 out of 9 options. So you do that subtraction. That's actually 9 over 9 minus 3 over 9, which is 6 over 9. It matches this probability here. Both ways work. Again, this way is often easier, especially if you have many, many, many options that you don't want to add up here. Great. The second main concept for today is called expected value. So you just learned about complement. Now we're going to look at something called expected value. The general formula for finding an expected value is E, representing expected value, is equal to probability of some event times the number of items in the sample you're taking or talking about. So here it has a watch factory notices that 6 of every 72 watches produced is broken. And the question here is, if you select a watch at random, what is the probability that it works? Okay, so these are broken watches, but you're looking for working watches. So you can begin like this. The probability of broken watch is actually the same as saying the probability of a not working watch. That means the same thing, right? So now we can say, well, we know the probability of a not working watch, which is this one here, a broken one, is 6 out of the 72 total watches. All right, so now we can reduce that to 1 over 12 as well by dividing both of these by 6. To take this a step further now, if we're looking for working watches, we know the broken is the same as not working, so we know that working is the same as 1 minus not working, all right, or 1 minus broken. So that can be rewritten as 1 minus 1/12, and that gives you 11/12. So the chance to get a working watch is 11/12, and that makes sense because if a working watch is 11 out of 12 watches, then a broken one is going to be the remaining 1 out of 12 is the broken one. But this is important to use this notation and understand how it works. Get used to that more than just finding that number, because I think finding a number is probably easy for you, but writing it properly is a little tougher. Question B, of every 3,600 watches produced, how many are expected to be broken? So now this is where we're going to use the expected value formula. Let's begin with that. We want to use the probability of broken watches multiplied by the number of items we're talking about in this sample here. And that means we do the probability of broken, which is 1/12. That's what we calculated here, times the total sample of watches we're taking, which is 3,600. If we multiply those two, we get that, and 3,600 divided by 12 is 300. So of this group of 3,600 watches, 300 are expected to be broken because that is exactly 1/12 of that value. Great, so try this one. Same idea, expected values, fruit shop. Shows you that fruit shop has the following fruits available. Frequency is a way basically saying of a count, all right? So there's 81 apples, 78 peaches. Make sure you are familiar with this word frequency as meaning count. So if you randomly select the fruit, what is the probability that is an apple? First, you'll need the total. If you add those up, it's 400. So that probability is 81 apples out of 400. What's the probability is an orange or a banana? Probability orange, or let's get used to this symbol. It means or. You could write the word or, but let's get used to this symbol. Or, okay, orange or banana is oranges is 75 out of 400. Bananas is that. They total up to this value. So that's the chance of getting an orange or banana. Next, if 5 of the peaches are rotten, what is the probability that a peach is rotten? This one's going to use a different denominator because if we're looking for a rotten peach, PR, then we have 5 rotten peaches out of the total group of 78 peaches, and that's the probability of getting a rotten peach in the group of peaches. All right, question 2 here though says, what is probability if fruit is rotten? So this changes what we're talking about. And then we have, okay, so what's the probability of getting a fruit that is rotten? And it's 5 out of the total 400, because those 5 rotten peaches didn't say that any others are rotten. All we know is that there's 5 rotten peaches, so it's 5 peaches out of the total 400 are rotten, so that's your chance. So now, if a larger order of 1,200 fruits is made with the same proportion of each fruit, then how many are expected to be peaches? Let's use the formula. Expected number is probability you get a peach times the number of items we're talking about. So probability of having a peach is 78 out of 400, and times the 1,200 sample here. You'll notice that 1,200 is just 3 times this value. So we're just taking the expected value of peaches then is 3 times as many as there are here. Because this is a sample of 400, now we have 1,200, so 3 times as many, and it works out right there. And finally, what is the probability, or sorry, the expected value of rotten fruits in this group of fruits? Same formula, probability of rotten fruit times number in our sample, which is 1,200 here. We take 5 out of 400 are rotten fruits times 1,200, and that ends up being 15. So it's like saying we've had 5 rotten peaches, but we're making this grow 3 times, so we're going to have 15. And last thing, this one is the one we looked at in class. There's 2 questions I'd like you to try here. First question is here, second is here. Read those and try to answer those. All right, let's check your work. So first one, you could do something like that. Take a look at that compared to what you did. And the second one, and the value, and answer there's 38. And the second question, you could use that formula to find out how many males we have. If it's 8.8 females, 91% males, and then calculate it like this. There's the answer. Hope that worked out for you. I hope you were able to apply these in more of a real life context here. And now make sure you do the practice assignment. There's lots